Mhm. Hello, hi everyone. Welcome to the Student the Brand. This is your Sibas sir. Today we are going to discuss about human eye in colorful world. Human eye and colorful world. Human eye is the most sensible and sensitive organ in our body. Okay. So without eye, we can't able to see anything in front of us, right? If you close your eyes, we can't see anything. Once you open your eyes, only we can able to see the beautiful world in front of us. Yes or no? Yes or no? Right? Yes. So today in this live class, we are going to discuss about human eye parts and function and refractive defects, myopia, hypermetropia, near point, far point, near point and far point, and presbyopia, cataract. After that, dispersion of light, white light, when it is passing through the prism, and formation of rainbow by water droplet. After that, we will discuss about. After that, we will discuss about atmospheric refraction and scattering of light. Okay, so we will discuss all these points. We will discuss about all the points. Let's start. So, as I mentioned, human eye is the most sensible and sensitive organ in our body, right? So, I'll draw the human eye, and how to draw the human eye also I'll explain. Okay, so after that we will discuss about parts and function in detail. After that we will discuss about refractive defects. Refractive defects. Okay, let's start. Let's start. Okay, human eye and colorful world. Human eye and colorful world. Human eye. Human eye and colorful world. Human eye and colorful world. Colorful world. Right? Yes. So now you can see here. Human eye, human eye, human eye. Human eye, human eye, human eye. Human eye and colorful word. Okay, so let's start the class. So I'm drawing the human eye. So generally we can take circle. So we can draw the circle first. So I will explain the methods to draw the human eye diagram. Methods to draw the human eye diagram. Simply we can take circle like this. Okay, so if you are not getting perfect circle also fine, no problem. Just to draw the circle. Okay, so if you are not getting proper eye diagram, so how to do? Actually, it is elliptical shape. Elliptical shape. So if you want to draw, you can draw in that way. Okay, so if you are not getting that shape, so at least you can make it a circle. So draw the circle shape. Draw the circle shape, and you can see here. Just I am drawing the shape of the eye diagram. Just you can follow here. Just focus on it. Okay. So here I am drawing complete circle like this. Okay. Just take it like this. Okay. So after that you can arrive this front portion. This the con bulged surface. Here it you can see. This is a cornea, frontal layer, protective layer, where most of the refraction takes place. Frontal layer, protective layer of the eye, where most of the refraction takes place at this part. And coming to the optic nerve. So optic nerve is this one. Here is optic nerve. Here is a optic nerve. So you can draw like this. You can draw like this. See, I am drawing like this. Okay. So you can draw like this. And here you can observe bulged surface like this. Okay, so like this cornea. This is a cornea. Okay, so you have to place the lens here. So this is the optic now. This is the optic now, and this one is the cornea. So you have to place the eye lens. So what is this lens? Convex lens. You can place the convex lens over here. You can place the convex lens. So after that, ciliary muscles, you can add those ciliary muscles. Ciliary muscles will be added to you here like this. So here you can observe. Okay, so you can see here. These are ciliary muscles. So which are holding the lens. So ciliary muscles will hold the lens. Okay. So like eye lens is there like this. So it will hold the lens at the top like this. So in middle it will be lens. Crystalline lens, eye lens or convex lens. Crystalline lens, eye lens or so anything. Crystalline lens or eye lens or convex lens. So all are same only. So now you can see observe. Observe here. Focus here so you can see here. Oh my god. Okay. Okay, so like this. And here you can observe. So the frontal layer, protector layer, where most of the refraction takes place at this part. Okay, so now we'll represent the label the diagram. So this is a cornea, and this one is the iris, and this portion also iris only. Okay, iris. And here you can see these are ciliary muscles. Okay, ciliary muscles. These are ciliary muscles. You can see here. Ciliary muscles. Okay, and this portion is called eye lens. Eye lens or crystalline lens. Eye lens or crystalline lens. Okay, so this the eye lens or crystalline lens. eye lens. Okay, so the liquid between cornea and eye lens is called aqueous humor. Aqueous humor. Okay, the jelly type liquid present between cornea and eye lens is called aqueous humor. Okay, aqueous humor. And this portion is the vitreous humor. Vitreous humor. Vitreous humor. And so here it is the retina. At this point, retina will be there. So you can observe here at this point retina. Okay, and you can draw. So these are optic now. Optic now. These are optic nerves. You can check here. This is the blind spot. And optic nerve. Okay, so this is about human eye parts. So here you can see this is the cornea, frontal layer, protective layer of the eye, where most of the refraction takes place at this point. Okay, whenever light rays enters through the cornea, most of the refraction takes place at cornea itself. That is a cornea. So here is a cornea. This is the cornea. And coming to iris. Iris is a dark muscular diaphragm which controls the size of the pupil. Iris is a dark muscular diaphragm. This is the iris. Iris is a dark muscular diaphragm which controls the size of the pupil. And this is the pupil. So this is the pupil. Pupil will control and regulate the amount of light entering into the eye. This gap is called pupil. Pupil will control and regulate the amount of light entering into the eye. Okay. And so eye lens. Eye lens is a crystalline lens. Whenever light rays falls on it, it converge and make it falls at retina. And coming to the ciliary muscles. Okay, so here you can observe these are the ciliary muscles. So this portion, both are holding the lens like this. Okay, at the top like this. So both are holding the lens. So normally in the camera, so we can able to zoom. Okay, if you want to see the nearby object as well as far object. According to that, we can adjust the camera, right? But so in reality, we can directly see, right? Okay, without any time taken. So immediately if you want to see nearby object, you can able to see. If you want to see the far distance object also, immediately we can able to see the far distance object. So which part is responsible for this? Ciliary muscles. Ciliary muscles are responsible for the adjustment of the focal length of convex lens. Whenever light rays are coming, so immediately it will adjust. If you are seeing the nearby object, it will adjust. If you are seeing the far by object, it will adjust the curvature of the eye lens. Ciliary muscles will adjust the curvature of the eye lens so that So eye lens can adjust its focal length. Eye lens can adjust its focal length. By that we can able to see nearby object as well as far distance object. We can able to see nearby as well as far distance object. Right? Yes. So these are the parts. First point is cornea and iris, pupil, ciliary muscles and eye lens. And one more thing, here you can see this is the aqueous humor jelly type liquid present between cornea and eye lens. Jelly type liquid present between cornea and eye lens. Okay, it provides is sufficient blood and nutrition to the central cornea. Aqueous humor is a jelly type liquid present between cornea and eye lens. It provides sufficient blood and nutrition. Okay. So next one, vitreous humor. So this entire portion is filled with vitreous humor. Vitreous humor is a jelly type liquid material present between eye lens and retina. Eye lens and retina. It provides sufficient force and pressure to maintain that shape. And coming to the retina. Retina is a light sensitive screen. Retina is a light sensitive screen. Okay. When our light rays are coming and meeting at retina, so the image will form at retina. So what is the nature of the image? Real and inverted. Real and inverted. Okay. Real and inverted. So that too 2D image will form at retina. Sir, how it is possible if it is forming 2D image? How can we see the 3D objects? So a glass is filled off of the water. So a water bottle is filled, so 3/4 of the water. How can we say like that? So when light rays are meeting at retina, so real and inverted image will form that to 2D image. So that will convert it in the form of electrical signals that will reach to the brain. Brain will add the additional information. That is how much depth it is, how much width it is, how much water is filled in the glass, how much water is filled in the water bottle, how far the object is from us, like that. Okay. So whatever I am saying, all the points are there in our CBSE textbook. Okay. So in the yellow box it is there. Okay. Okay. So whatever I am teaching, all the points, whatever reference points, whatever I am teaching. Okay. So all these sentences are taken from the CBSE textbook. You can check once. In the yellow box they will give like that. Okay. So when you are seeing the nearby object, far by object, so the points also will be framed in the textbook itself. You can check all the points. Whatever I am mentioning the points. Okay. So those points are from the textbooks. Okay. So whatever the parts and function and everything. Okay. Right. Okay. So now where we are at retina. What type of image will form at retina? Real and inverted and 2D image that will convert in the form of electrical signal that will pass to the brain through optic nerve. So here is the optic nerve. This is the optic nerve. This will carry the electrical signal to the brain. So sir, what about blind spot? Sir, what about blind spot? Blind spot. So here there light rays will not reach to this point. Light rays will not meet at this point. Where nerves are reaching to the brain. All nerves are reaching to the brain. Okay. Yes. That point is called blind spot. So this is about human eye parts and function. Human eye parts and function. Once again. So I will ask questions. So just now, till now I explained the eye parts and function, right? So I'll ask questions. Let me know the answer. So what about cornea? So what is the function of cornea? Is it print layer, protective layer of the human eye? Most of the refraction takes place at this part. So immediately, so this is the front layer. Whenever light rays comes, so it will incident on this layer, then it refraction takes place. Next one, iris. What about iris? Iris is a dark muscular diaphragm which controls the size of the pupil. People will control and regulate. Okay, through the people only, the light ray will enter. Through this part only, the light ray will enter. Okay. So on the eye lens, whenever light rays falls on it, it converts the light rays and make it falls at retina. Yes or no? Lens. Ciliary muscles. So power of accommodation is related to this part. Okay. Which is responsible for power of accommodation means ciliary muscles. How it is? Okay. So ability of the eyelens to adjust its focal length. Okay, here. So which one is helping to adjust the focal length? Ciliary muscles. Ciliary muscles are adjusting the curvature of the eyelens so that eyelens can adjust the focal length to allow the light inside of it when you are seeing the nearby object as well as far distance object. Nearby object as well as far distance object. When you are seeing the nearby object, eyelens will be thick, focal length is decreases. Okay, power will be more. Focal length is less, power will be more. When you are seeing the far distance, that time ciliary muscles will be contracted. Ciliary muscles will be contracted. Eyelens thickness will increases, power increases, focal length decreases, so that we can able to see the nearby object. When you are seeing the far distance object, ciliary muscles will be relaxed, eyelens curvature will be thin, okay, so reduces, so eyelens will be thin, so that focal length increases, we can able to see the far distance object. And here two more points. Those are near point and far point. Sir, what is near point? What is far point? Near point is nothing but the minimum distance up to which a person can able to see clearly without any strain is called near point. The minimum distance up to which a person can able to see clearly without any strain. A healthy person can able to see clearly without any strain, that is called near point. So, and one more point is here, least distance of distinct vision. Least distance of distinct vision. Okay, so the minimum distance up to which a person can able to see clearly without any strain is called near point. Okay, so if I place this object, if I place this marker, so less than 25 centimeter, I can't able to see this. If I place the object less than 25 centimeter, I can't able to see that object. Okay, so certain time. So if I place like this, immediately maybe, but after certain time, our eyes will get strain and pain. Okay, ciliary muscles can't contract below certain limit. Okay, so it can't contract below certain limit. Okay, then automatically our eyes will get strain and pain. So the minimum distance is required to see the object clearly without any strain and pain. That is called near point. Near point is 25 centimeter. Near point is 25 centimeter. Okay. So coming to the far point. The maximum distance up to which the person can clearly see without any strain. The maximum distance up to which a person can able to see clearly without any strain. A healthy person. So it's not about defects. So a healthy person can able to see clearly without any strain. That is called far point. Far point is infinity. Far point is infinity. What about range of vision? What about range of vision? Range of vision is 25 centimeter to infinity. Okay, so the person can able to see clearly without any strain. Okay, so range of vision is 25 centimeter to up to infinity. Okay, I hope it is very clear. So near point, far point, least distance of distinct vision, and human eye parts and function. So what are those? Cornea, aqueous humor, iris, pupil, ciliary muscles, eye lens, vitreous humor, retina, blind spot, optic nerve. So here one more thing. At retina, there are two types of light sensitive cells out there. Those are called rods and cones. Those are two light sensitive cells. One is rods, another one is cones. Cones. Rod can sense the intensity of the light, cone can sense the color of the light. Rod can sense the intensity of the light, cones can sense the color of the light. Color of the light. If more rods are there, then we can able to see clearly during night time also. If more rods are there, we can able to see during night time also. Okay, more cones are there, we can able to see the colors. Right? So this is about human eye parts and function, a near point, far point, near point, far point, the least distance of distinct vision, all those points we discussed. Right? Now, so we'll discuss about refractive defects. So while you are aging, the eye lens can't refract. The eye lens can't refract properly the light rays. Okay. So actually, when light rays falls on it, when light rays falls on the lens, those light rays will refract and then it falls at retina. Okay, it falls at retina. But when you are aging, the lens cannot refract the light rays properly. Lens cannot refract properly. So that the defects will arise. So students, so those who are there in the live class, please, so click on like button, share to everyone as soon as possible, because no important topics I'm discussing. So I'm doing so much hard work for you all. Just can you just do help in that way to reach to the maximum students. So I need your help. So support the channel, support me, share to everyone, inform to everyone. So live class is going on. Just click on the like button, subscribe my channel. Okay, inform to everyone. Okay, because the live class is going on, that important topic is going on. So just let me know to teach maximum students so that I can able to reach to the maximum students. So in that area, I need your help. I need your support. Without support, I cannot reach to the maximum students. I cannot reach to the, okay, I cannot no, my subject cannot reach to the maximum students. Instead of me, my subject cannot reach to the maximum students. So those who are in need. So with your help only I can able to reach. So try to share, try to subscribe, and just if you like the content, if you like my channel, if you like my channel, if you like the content, okay, so please సబ్స్క్రైబ్ చేసుకోండి, లైక్ చేయండి, షేర్ చేయండి, ఇన్ఫామ్ చేయండి అందరికీ. సో మన క్లాస్ జరుగుతుందని, ఫిజిక్స్ క్లాస్ జరుగుతుందని అందరికి తెలియజేయండి. ఓకే, సో ఐ నీడ్ యువర్ సపోర్ట్, ఐ నీడ్ యువర్ సపోర్ట్. థ్యాంక్ యూ సో మచ్ ఫర్ సపోర్టింగ్. బట్ సో ప్లీజ్ షేర్ ఇన్ దట్ వే, ఇన్ఫార్మ్ టు ఎవ్రీ వన్, inform to everyone, ask your friends to join to the class. Okay, so please click on like button and share to all. So do support in that way. Thank you so much for your support, those who are doing so indirectly or directly. So thank you so much for them. Thank you so much. So okay, so thank you so much. So let's start. So those are supporting, I'm very happy for it. So please share to everyone, share in all your groups, share it to all your friends. So inform to everyone. So click on like button. So I need your support. Thank you so much. So let's start. Refractive defects. Here we are discussing about myopia. Okay, so refractive defects, they are there. One is myopia, another one is hypermetropia. Next one is myopia, another one is hypermetropia. After that presbyopia. After that we will discuss about cataract. After that we will discuss about cataract. After that astigmatism. So let's start myopia. Myopia, myopia, myopia. Myopia, myopia, myopia. Near distance we can see. Near distance we can see. Far distance we can't see. Myopia, myopia, myopia. For that correction we are using. Bro, what bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So here the song itself is saying near distance we can see, far distance we can't see. For that correction we are using okay, yes, where we are. So the song itself is saying near distance we can see, far distance we can't see. Near distance we can see, far distance we can't see. For that correction, we are using concave lens. For that correction, we are using concave lens. Let's start. Okay, so this is about so myopia. Myopia is nothing but the person can able to see clearly near distance. He can't see the far distance object. Yes or no? Yes or no? The person can't able to see clearly far distance, but he can see near distance. But one thing, between 25 to infinity, he can see somewhere in the middle. Between 25 to infinity, he will see at the middle of that point. That is called far point of myopic eye. Yes. This is the far point of myopic eye. Far point of myopic eye. The person can able to see this point. If the light rays are coming from this point, those light rays will meet at retina. So that is defect only. Why? Because we can see only that point. Okay. So here we can able to see this point. But we can also see this point. But we can't see this point. Yes or no? If the light rays are coming from far point of the myopic eye, where those light rays will meet? I said right, those light rays will meet at, we can able to see that point. If you are able to see that point, then automatically those light rays will meet at retina. Yes or no? The light rays will meet at retina. Are you agree with me or not? So if the light rays are meeting at retina, then we have to draw the diagram, no? Yes or no? We have to draw the diagram. I will draw the diagram, just observe here. So this is the near point N and this is the far point F. So light rays are coming from this point. Yes or no? Light rays are coming from that point. After refraction, where those light rays will meet? At retina. Why? Because we can able to see that point, right? We can able to see that point or not? Yes. So if you are able to see that point, then those light rays will meet at retina. So just check once. So these light rays are meeting at retina. Yes or no? Yes or no? Yes or no? Yes or no? What is this one? Near point. What is this one? Far point. As I said one thing. As I said one thing. If the light rays are coming from infinity, those light rays will meet at retina. Will they meet at retina? No. Why? Because we can't able to see. If the light rays are meeting at retina, only we can able to see. If the light rays are not meeting at retina, we can't able to see, right? We can't able to see. So now I am drawing. Now I am taking the light rays from infinity. Now I am taking the light rays from infinity. Check here. So I am taking light rays from this point. Okay. So here this is the normal point and this is F. Light rays are coming from like this. Okay, after refraction, those light rays are meeting in front of the retina. Yeah, 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 yeah. Okay, those light rays are meeting at in front of the retina. Okay, so we need to correct the defect. We need to correct the defect at any cost. So what lens we have to use? What lens we have to use? We have to use concave lens. We have to use concave lens to correct the defect. What is this defect? Myopia. Yes or no? Yes. Check once here. So what is this point? What is this diagram name? Far point of myopic eye. What is this one? Far point of myopic eye. Far point of myopic eye. Myopic eye. What about this one? Myopic eye. Myopic eye. Myopic eye. Myopic eye. Yes or no? Now we are using concave lens. Concave lens. Dun, 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 dun. Da, 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 da. What is this lens? Concave lens. What is this lens? Concave lens. So light rays are coming from infinity. Light rays are coming from infinity after refraction. Those are moving away from the principal axis. After that, so we are taking the light rays from this is N, this is F. So here you can see, okay. So what is this diagram? What is this diagram? Correction of myopic eye. Correction of myopic eye. myopic eye. Okay, so check once. So is it correct or not? Is it correct or not? Far point of myopic eye. Far point of myopic eye. So if the light rays are coming from this point, we can able to see. If the light rays are coming from this point, we can see. That's why those light rays are meeting at retina. And here you can observe, if the light rays are coming from infinity, those light rays are not meeting at retina. So those are meeting in front of the retina. Okay, those are meeting in front of the retina. In front of the retina. So this is a near point, far point. These dotted lines represent light rays are coming from infinity. And in the here in this case you can observe. So we used concave lens. Concave lens. So if you are extending from this lens, the light rays will meet at focus from here, this point. Okay. So far point of myopic eye, correction of myopia. So this is also defect on. So we can see only that point. Understood or not? Myopic eye, correction of myopia. Right? So next one, hypermetropia. Hypermetropia is nothing but the person can see only far distance object. He can't see the near point. The person can see the far distance object. He can't see the near distance object. But between 25 to infinity, somewhere in middle of the 25 to infinity, he can able to see. Okay. So that is the near point of hypermetropic eye. Near point of hypermetropic eye. So now I will draw the diagram. So meanwhile I will sing one song for you. Hypermetropia, 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 hypermetropia. Far a distance we can see, near distance we can see. Far a distance we can see, near distance we can see. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, 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 hypermetropia. Far a distance we can see, near distance we can see. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Okay, so that is about hypermetropia. So we can see now. I'll give one incident so that you can understand. Then I will draw the diagram. Hypermetropia, hypermetropia, Hypermetropia. Hypermetropia. For a distance we can see, near distance we can see. For that correction, we are using convex lens, convex lens, convex lens, convex lens. Okay, so like that we can see the person who has hypermetropia can see the far distance object. So no problem. He can able to see this point. But he can't see this point. But one thing between 25 to infinity, somewhere in middle, he can able to see the point. Okay, that is the near point of hypermetropic eye. Near point of hypermetropic eye. What is that? Near point of hypermetropic eye. How to draw the diagram? Just check once here. Na, 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 na. Na, 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 So if you like the content, if you like the channel, if you like my videos, if you like my explanation, do like, share and subscribe to Student the Brand. Do like, share and subscribe to Student the Brand, right? Yes, so here you can see. Okay, done. So my name is Siva sir. Okay. Yes. So if the light rays are coming from light rays are coming from N dash. Those light rays will meet at retina. Yes or no? Yes or no? Yes. That is the near point of hypermetropic eye. Near point of hypermetropic eye, right? Yes, near point of hypermetropic eye. Near point of hypermetropic eye. Hypermetropic eye. Yes. And coming to the next one. So here you can see, here you can observe the light rays are coming from the, here you can observe, here you can observe if the light rays are coming from 25 centimeter, if the light rays are coming from the If the light rays are coming from 25 centimeter, where those light rays will meet? Beyond retina. Okay, so here you can see. So this is N, 25 centimeter, this is N dash. Okay, light rays are coming from this point. Yes or no? If the light rays are coming from this point, so you can see here. So those light rays are meeting here in this case. Where those light rays are meeting? Beyond the retina. So at this point, okay. So this is the hypermetropic eye. Hypermetropic eye. Hypermetropic eye. Okay. Hypermetropic eye. Like this. So, which lens we use to correct the defect of hypermetropia? Which lens we will use to correct the defect of hypermetropia? Convex lens. What lens? Convex lens. Just we will draw the diagram. Okay, check once. So now you can see here near point of hypermetropic eye, and this one is the near point and end dash. Okay. Correction of hypermetropic eye. Okay. Correction of hypermetropic eye. Correction of hypermetropic. Okay, so like this you have to draw the diagrams. Observe carefully. So you can observe the first diagram. So if you know this concept, these diagrams are very easy. So in easy way, simple way, you can draw these diagrams. First you have to understand this concept. So the concept is the person who has hypermetropic eye, he can able to see from far point. He can able to see from far point. but he can't see the 25 centimeter. If the light rays are coming from 25, from that point, he can't able to see. Okay. But one thing, between 25 to infinity in middle, so in between that point, okay, so between that point he can able to see. That is a near point of hypermetropic eye. Near point of hypermetropic eye. So if the light rays are coming from this point, so this is the diagram. Near point of hypermetropic eye. Okay. So here this one, if the light rays are coming from 25 centimeter, so near point is 25 centimeter, 25 centimeter, and end dash is the near point of hypermetropic eye. Near point of hypermetropic eye. Okay, hypermetropic eye means those who has hypermetropia. Okay, so it shift this point is the near point for that person, right? Now you can see this is the point. Now these light rays should meet at retina. Okay, so which lens we will use to correct this defect? Convex lens. Convex lens. Actually in the eye, so inside of the eyeball, eye lens will be there. That is also convex lens. And we are using convex lens to correct the defect of hypermetropia. Okay. So I hope it is very clear. So be aware of it. All these diagrams, very, very important. Okay. So 5 marks question will be expected from this concept, especially from myopia and hypermetropia. Myopia and hypermetropia. Okay. Simple. At the same time, I given songs also. So that is for remembering sake. Whatever songs I given to you, like a song for you, those songs just for remembering sake. Okay. To identify the concept. So what is myopia? What is hypermetropia? Okay. So first on myopia. So short sightedness, near sightedness. The person can able to see clearly near distance, he can't able to see far distance. For that correction, what we are using? Concave lens. In hypermetropia, we can able to see far distance, but he can't see the near distance object. For that correction, we are using convex lens. For the correction of hypermetropia, we are using convex lens. I hope it is very clear, right? So coming to presbyopia, the person can't able to see near distance as well as far distance. Presbyopia can't able to see near distance as well as far distance. For that correction, we are using bifocal lens. So upper portion is concave lens, lower portion is convex lens. Okay, bifocal lens. And coming to the cataract, while you are aging, so a milky and cloudy will form an eye lens. Okay, so while you are aging, so you can observe the people has milky and cloudy on their eyes. Okay, that is called cataract. Cataract. By using laser surgery, we can remove that defect by cataract surgery. By laser surgery only we can remove the cataract. Okay, next one, astigmatism. The person can't able to see the horizontal lines and vertical lines and horizontal lines. So by using suitable cylindrical lens, we can correct the defect of astigmatism. Okay. So these are the defects. Next, we will discuss about colorful phenomena. Okay, let's start. Colorful phenomena. So now, colorful phenomena. So now we'll discuss about the colorful phenomena. Okay. So I'm considering the prism. This is a prism. Light rays are incidenting on it. Okay. So if the light ray incident on it, so we can see here the splitting of white light into 7 colors is known as dispersion. Splitting of white light into 7 colors is known as dispersion. Okay. So now you can see here. 1, 2, 3, 4, 5, 6, 7. The splitting of white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen. Those 7 colors will form like a band on the screen, that is called spectrum. Okay, so you can observe here. Violet, indigo, blue, green, yellow, orange, red. VIBGR. Violet, indigo, blue, green, yellow, orange, red. VIBGR. Okay. So splitting of white light into its constant colors is known as splitting of white light. Its constant colors. Okay. So you can see here. Violet, indigo, blue, green, yellow, orange, red. So VIBGR. Okay. So these are the 7 colors. These are the 7 colors. Okay. Splitting of white light into 7 colors is known as dispersion. Those 7 colors will form like a band on the screen is known as spectrum. Okay. So you can observe when light ray passing through the prism, it's split into 7 colors. Those 7 colors will form on the screen like this. So in the rainbow, so in the sky, you can observe the rainbow. 7 colors, right? So 7 colors will form in the sky. So how it will form? Now we'll draw the diagram. You can check here. When light ray passes through the water droplet, so like here I am taking, it's split into 7 colors. Split into 7 colors. 1, 2, so like this. Okay. Understood? So here, what is the phenomena involved? So actually violet deviate the most and red deviate the least. That's why violet is at the bottom and red is at the top. So violet and red, violet and red, violet and red. Okay. So what is the phenomena involved in the formation of rainbow? What is the phenomena involved in the formation of rainbow? Refraction, dispersion, internal reflection. refraction, dispersion, internal reflection. Refraction, dispersion, refraction, dispersion, and internal reflection. Internal reflection. Internal reflection. Okay. So the phenomena involved in the formation of rainbow. The phenomena involved in the formation of rainbow is refraction, dispersion, internal reflection. Okay. Right. Next. So we'll discuss about recombination of spectrum of white light. Recombination of spectrum of white light. Let's start. So, Newton sent the white light through the prism. It's split into 7 colors. So, still further he want to split the colors. So, what he did, he placed the same prism besides of the first prism. So, he couldn't able to disperse further. So, what he did, so he placed the inverted position of the prism near to the first prism. Inverted position of the prism near to the first prism. Then if you send the white light, okay, so here you can observe. Violet and red, violet and red. So on the screen, this is the screen, white light. White light. And here you can observe, this is the source of light. From here, white light is coming. White light. White light. Okay, so this is the prism 1. This is the prism 1. Prism 2. Prism 1 and 2. Well, white light ray passes, it's split into 7 colors. Those 7 colors will form on the inverted prism. So again that will be converted and we will get it as a white light outside on the screen. Okay, so now refraction, atmospheric refraction. Generally we know refraction of light. The bending of the light and the interference of the two media is called refraction of. Generally that is the refraction. So refraction takes place by the atmosphere. Refraction takes place by the atmosphere is called atmospheric refraction. Atmospheric refraction. So the person is standing, the person is there another side of the fire. So fire is in middle. So person A and person B. So in middle fire is there. So person is seeing the person A through the fire. Okay, what happens? Light ray will enter into the hotter air and colder air. Hotter air and colder air means it changing its medium. then automatically the person who is there, another side of the fire, it appears flickering. The image of the person is appearing flickering. Actually, the person is there only, but so when you are seeing through the fire, so it appears to be flickering. Okay, na? Like that. So, due to atmospheric refraction, due to atmospheric refraction. So, you can observe the twinkling of stars. Twinkling of stars. Light ray is coming from the stars, it keep on changes its direction. By reaching Earth, it appears to be twinkling due to atmospheric refraction. Okay. And one more point, you can see advanced sunrise and delayed sunset. 2 minutes advance and delayed sunset. 2 minutes advance and delayed sunset. That is also atmospheric refraction. And coming to the colors of the light. Colors of the, so if you are in the morning time and noon time, and in the evening time, morning and evening, sun appears reddish due to scattering of light. Whenever light rays releases, so it scatters, it is light rays scattered by the atmosphere. Only red light travels long distance because it has longer wavelength. Because it has longer wavelength. Okay. So sky appears blue color. So due to scattering of light by the atmosphere, so all colors will scatter the most. So immediately, so it scatters. So smaller wavelength of the light scatter the most. So whenever the light ray releases, blue light is scattered the most. That's why it is visible. And deep sea also due to scattering of light. What is the scattering of light? Re-emission of light in all directions with a different re-emission of light in all directions with a different intensity is called scattering of light. Okay. And the Tyndall effect. Tyndall effect is nothing but the path of the light becomes visible when it is passing through the colloidal solution. When light ray passes through the colloidal solution, due to colloidal solution, the light ray will scatter in all directions with a different intensity. So when you, in the morning time, you open the window, a beam of light falls on the ground, so on the floor, you can able to see the dust particles flying due to scattering of light. Okay. So that's enough. This is about human and colorful world. So if you like the content, if you like the channel, if you like my explanation, do like, share and subscribe to Student the Brand. So please share to your friends, ask your friends to join to the class and inform to everyone. Okay, so live classes will go on continuously. So let everyone knows. Please do like, share and subscribe. If you like the content, if you like the explanation, if you like the channel, you can go for super chat, super thanks, and be a member to the channel also. Okay. Thank you so much. We'll see you in the next class. Signing off.